go to this second method, which is method bisection. This is several simple steps to be followed in order to solve this problem using method bisection. Okay, so the first step, like I'm saying before, it is same for both method, which is draw overall free body diagram and solve to get the value of forces at the end or at the boundary condition of the structure. Okay, like this one we have already calculated. Then we have the Ax, which is 0, and we have the Ay. Okay, so we can solve this using three equations: sigma fx, sigma fy, and sigma moment at any point equal to 0. This is the second one. And then choose part with 3 members only to be cut. Meaning that, let's say if we have a component like this one, okay, let's say we have this component. Okay, so one saying by choose part with 3 members only, meaning that in the method bisection we have to cut the component into 2 sections. Okay, so if let's say we want to cut the component, it is here, choose part with 3 members only, so meaning that we can cut it maybe here. So if we cut here, you can have 1, 2, 3. Okay, so or if you want to cut it here, you can also have 1, 2, 3. Okay, so the thing said here is choose with 3 members only. It is to say that you cannot choose to cut from maybe this direction. This direction. You will have 1, 2, 3, 4, and 5 components. If you cut it to this direction, you will have 5 components. Okay, you can cut only the component that have 3 members. The reason is when you cut the component and when you want to solve, you will have to use these 3 equations: sigma fx, sigma fy, and sigma moment. If you have more than 3 members, meaning that you will have more than 3 unknown, because the force inside is the unknown. Okay, if you have more than 3 unknown, you cannot solve. So in order for you to be able to solve, you must choose the cutting point that will lead you to only 3 unknown. Only 3 unknown. Okay, so that's why you can cut, but you have to choose wisely. Choose simple section, less force in x and y direction, and simple dimension. So meaning that if I have this one, if I cut here, I will have 2 sections. The first one is half here. Okay, see, and this way. The other section is this way. Okay, this is the other section. Okay, and then you have to choose either to do the analysis using this part, left hand, or the other part, which is right hand. Okay, and when you want to choose, we said here, less force, and then force in x and y, and also simple dimension. Meaning that at the end here, when you do the free body diagram, here maybe you will have force here, x and y, and here force 1, and then here is 1 force, here is 1, and the other part is there, 1 force. Okay, at the end here, maybe you only have 1 force like this. Okay, for example, if you have this force. Okay, seeing from here, maybe it is simpler for you to choose this part, because you only have 1, 2 force in y, in x, and only 1 that have the angle. So only 3 forces. So we should have 1 more here. 1 more. This is there. So this is here. Okay, 1 here and 1 here. Okay, so we have 1, 2, 3. Okay, 2 here and 2 here. But if you look at from here, you have 1, 2, 3, 4, 5, 6. Okay, so in this case, maybe it is simpler for you to use this part for calculation instead of using this part. You can also solve, but it will take you just a little bit more time. And in terms of dimension also, if the dimension of this part is directly given for you straightforward, and you know what is here, okay, instead of here maybe it is a complex dimension, you didn't know what is the dimension here, and so on. So you have to choose the one that is easier for you to calculate. Okay. The reason is we want to cut it short, the calculation. Okay, and in lesser time you can get the answer. Of course, normally you can have either side, you can have the same answer. Okay, both sides you can have same answer, but which one gives you shorter time to solve? Okay, that's all. So that's why we said here, find the component that have less force in directly xy and xy. You don't have to resolve into x and y. For example, here you have to resolve some if you have in other direction, and then simple dimension. Okay, for easier for you to take the moment and so on. So that's why. And assume all unknown force to be intention like this one, which is out of the component. That's why I'm drawing here. When I cut it here, all is to outward, same as this one. All is outward of the component. And lastly, we can solve using sigma fx, sigma fy, and also sigma moment. That is the 3. Okay. There's some if the question didn't ask you to use either method by join or method by section, you can choose on your own. But some of the question directly said to you, use this method or the other method, or use both method to prove that same answer. Okay. So if you are asked to use both method, you just use. But if you are not asked to use both method, you can choose. And some simple guide for you to choose which method. For example, if I have this same one. Okay, and let's say I have this one, same component. Okay, so let's say we have this component. Okay, depend on the type of question. If let's say question asks you to find the force inside this component, 1, 2, and 3 components. But the other part, question asks you to find the force in this one. This one, the question wants you to find the force in these 3 part, but this one is the other 3 part. Okay, so looking from this component, normally if I'm free to choose this one, I will use directly method by bisection, because if you want to cut the component, you can cut directly here. One time you cut, and again then you get all the 3 components. But here, if you cut it here, same, you only have 1. So you have to repeat again the process. Maybe you cut from this direction, and you get 1 more. Okay, and or if you can also use this direction. Maybe you can have 1 here and 1 here too, and you have to cut another 1 here. So at least you have to use 2 times to get the answer. But if you use method by section, but if you use method by join, you can use this join here to get all the 3 forces. So really depend on the component, where on the structure and the question where the component is asked. Okay, if you can directly using a straight 1 time you cut, you get all the component, you go method by section. But if not, you have to think for the method by join, either it is simple or not. For this one, maybe it is directly simple because you use only 1 point, and then you get 1 join, and then you get all the answers. So it's the way to choose method by join or method by section, simple one. Okay. If the question asks you what method to be used, you have to follow. But if not, you might think of this one to choose which method to be used. Okay. So again, if you can easily cut 1 time and then you get the answer directly, you can use method by section. If not, think about method by join. So I will use the same example, this one, to demonstrate the way to use or to solve this problem using method by bisection. The first method I've already showed, using method by join. Now it is method by section. So I will stick to the same question. The first step is for you to draw overall free body diagram, which is this one, and solve for the point which is at the end of the point. Okay. So we have calculated that one, and we have E equal to 4.25, AY equal to this one, and AX equal to 0. That one you use the same method, the same process, method by joint or method by section. The first step is same. So please go back to my previous video and see how we calculate that one. It is just to draw overall free body diagram and calculate using sigma fx, sigma fy, and sigma moment. So you got this. So the second step is you want to cut this one into two pieces, okay, two sections. In this case, we directly can see that it is here, the one that is asked to you. So it is simple. If you cut it here, you can directly have the answer 1, 2, and 3 component. Okay, and then you can choose which part you want to solve, left hand or right hand. Okay, in this case, maybe you see that here we have 1, 2 forces. Here you have 1, 2, 3 forces, and the length or dimension of this second part is more difficult than this first part. So of course, in this case, I will choose the left hand. So I will choose to use, okay, I will use this part, left hand part. So this is right hand, I will not choose in this case. So I will use this one. So that's the consideration you might want to do. Okay, so if you use this one, you will have the force as, drawing back the free body diagram. This is the part, and we cut it here, and this is down there. Okay, A, H, B. So you have cut the component here. Okay, so I leave the component there. So you want to draw the force that you know, which is H downward 3 kilonewton. This is 2. The height of this one is 3, and the other one is that one. And we have here AY, which is 4.75, and that's all. Okay, and then our third step is to say that all the unknown forces is in tension. Put it first in tension. So this is the one that we cut and we didn't know. So B 1, 2, 3. So the force is in tension, meaning outward of the component. So you put it straight away, upward. F, B, C. Down here, F, D, G. The other one is F, H, G. Okay, so assume first all the component is in tension. And why I'm doing only one force here, not X, Y, S, Y, and so on, because we already said here all the component inside the trusses is a two force member. So that's why it is only one force like this one. Okay, it is all two force member. Okay, 2 point where we have the force, so the force is same, so it become this kind of force. Okay, now we have 3 unknown, 1, 2, and 3, and then we have 3 equations, sigma fx, sigma fy, and sigma moment. Of course, we have to calculate here the angle, which is 36.87, here is 56.31, and that's all. Okay, so we can solve using sigma fx, sigma fy. Maybe we go to the first sigma what? Sigma, we have, if I'm solving from point here, H, I will have 2 unknowns, so maybe I go to directly at point B. So I will go, this one positive, sigma moment B equal to 0, this one. Okay, so I can ignore this. So B, we have 4.75, pull this direction positive. The distance is 2. This one pulling this direction, so negative, minus FG, the distance is 3. We have FSG, this is equal to 0. Okay, so we have FSG, which is 3.17 kilonewton. Okay, same as what we have calculated before. So it is positive. We assume everything is in positive. We got the intention. We got the positive answer. So the value is in tension. So the first answer is in tension. Okay, and then we can go to sigma fx and sigma fy. We have two more equations. So let's say we go to sigma fx equal to 0. So we have FBC, this one, cos 36.87 plus FBG, okay, this one, cos 56.31 plus FGH, which is plus 3.17, 1, 2 and 3. So equal to 0. So this is the first equation. Because I have two unknown here, 1 and 2, I cannot solve. So you go to upward positive, Fy equal to 0. We have FBC sin 36.87 minus downward FBG sin 56.31. Okay, this is in Y also. So plus 4.75 minus 3 equal to 0, equation number 2. So we have two equations here and two unknown. One FBC, FBG, FBC, FBG. Okay, you solve 1 and 2. You solve 1 and 2 and then you will get the answer as, first you put the equation this one, equation number 2 inside equation number 1, and then you get the first one I got what, FBC equal to negative 3.61 kilonewton. So FBC equal to 3.61 kilonewton in compression. Okay, because it is negative, it is in compression. So put back this equation. So I'm always stressing this one. You put the value in the equation from the calculation, not the what we here. What we have. This is what is our interpretation. Negative meaning what? So, but in our calculation, if you want to continue calculation, please put the original value, which is this. Put in equation number 2, and then you got the answer as FBG equal to negative 0.5 kilonewton, which is FBG 0.5 kilonewton in also in compression, both in compression. Okay, so that's it. We have same answer as yesterday. Okay, as our previous video. Using the first method, you see that we have a much longer way to calculate. We have several points, 1, 2, 3, and then we have to go from this point and go back to this point, and lastly to go to this point to get all the component. So it may take you longer time using method by joint, whereas if you use method by section here, you only want cutting it one time and then you get all the 3 parts that is needed. So directly you can have the answer. It is much easier for you to solve this problem. Okay, so that's it. If the question asks you to use both method, you don't have the choice, you use. But if you have the choice, think about it. If you can cut only one time and you get all the answer, you use method by section. If not, you use method by joint. Okay, if it's complicated, maybe the one that is asked to you, this is one here and one here and one there, so it is easier for you to use method by joint in that case. But in this case here, it is clear that using method by section is much more easy. So you cut one and then you choose either right one or left one. Okay, so in this case I'm using this one because it is the dimension is simple, the component is lesser, the forces also is lesser than the other part. So I'm using this one here, and then using sigma moment first. Normally we use the sigma moment that we can directly have the answer, and then sigma fx, sigma fy. And again, please, this answer is from your calculation, so if you want to put back in your calculation, use the original answer, which is negative. This is our interpretation, negative meaning that in compression, because we assume everything is in tension. Okay, so put back in the equation, you get the second answer, which is also negative, meaning that it is in compression. And please write the answer this way, which is we have the magnitude and the condition. Because the question normally asks you what is the magnitude and also in tension or in compression. You have to write that one. If you don't write that one, you will lose some mark. At least if you don't want to write the whole tension or compression, just put it as T or C. At least that is your answer. Okay? So I hope this is clear for you. Thank you very much. See you again. Assalamualaikum.